Welcome everyone. So today we are going to address an important concept or a particular graph called the ogive. And an ogive is a way for us to figure out percentiles of any sort, not just the special ones like the 50th percentile or the 100th percentile or the 75th. We could figure out any percentile we want. So that's the purpose of today's presentation. The example I have here is we took all the first 43 US presidents, and we recorded their age at the time of inauguration. So we're ignoring Obama and Trump, just the first 43. We looked at their age, and I don't remember the minimum and the maximum, but they are somewhere between maybe 41 and 68 or something of that sort. So we picked nice numbers starting with 40 and ending with 69, which basically gives me 30 years, right? It gives me 30 years. And we basically recorded the number of presidents, like for this category. We found out that there are 2 US presidents at inauguration who were somewhere between 40 and 44 years old. And because we have 43, for one, it doesn't make sense to use, let's say, stem and leaf plots or box plots because the number is large. But the other reason, which is more important, is because I am interested in the ogive, it makes perfect sense to pretend that we are going to do a histogram. Okay, so this is how we do a histogram against that. So that's why we are using this approach. So we have 30 years between 40 and 70 or so, and we split them into 6 categories. So each category will include or will involve 5 years, right? 5 times 6 is 30. So between 40 and 44 inclusive, there are 5 years: 40, 41, 42, 43, 44. Okay. And we basically record those numbers. Now, I think this is even better because this tells you part of a whole. That just tells you the parts. So if you say that there are 2 presidents who were between 40 and 44, is that a high number or low number? I have no idea, right? Is it 2 out of 5, or is it 2 out of 43, or is it 2 out of 1,000, right? So a relative frequency, these percentages, as you've seen in middle school, these percentages, in my view, are better than this. So if you do a histogram, for instance, on the x-axis, you're going to have the class, right? And you're going to have 6 buckets. On the bars, let's say this is the first one, okay? So this is, let's say, 40, 44. And let's say this is 2. I think it's better to say 4.7%. So if you look at the relative frequency, it tells you that this is fairly small, right? 2 is almost inconclusive. Is 2 a high number or a low number? I really don't know unless I consider my total of 43. Okay, so I think it's better, if you want to do a histogram, it's better to do a relative frequency on the y-axis against the class on the x-axis. So of course we compute the frequency just so we can find the relative frequency: 2 out of 43, 6 out of 43, 13 out of 43, and so on and so forth. You could leave them as fractions, or you can write them as percentages. I think this is better. Because I can feel what 4.7 means, even though this is a relative frequency and this is a relative frequency. It's not; these are all better than this for sure, but this percentage is better. So I would say you want to put these relative frequencies against this. Okay. So let's move on. Now, that's not the purpose of today. The purpose of today is to get to the last column. Okay, and we can't get to the last column without this column. So now, a similar column to this one is called cumulative frequency. So basically, these are frequencies, and so as these, but these are cumulative. So on the first one, it doesn't change. Up to now, I have 2, but up to the age of 49, I have 2 plus 6, so that gives me 8. So you are accumulating. And then because I have 13 here, when you add 8 to 13 to 8, you're going to get 21. The last one should always be 43, of course, because you are accumulating their ages. So this 33 is the age of presidents up to the age of 59. Not starting with 55, but starting from the start, okay? So this is cumulative frequency. And just like we did this by looking at the frequency over the total, frequency over the total, frequency over the total, we're going to do the same thing here. The cumulative frequency against the total, cumulative frequency against the total, and so on and so forth. The last one is the cumulative frequency against the total. The last one should be always 100%. So to do an ogive, all you have to do is take these percentages and sketch them against the class. So here is the class, and here are your percentages. And the first one is a percentage of 4.7. So this point here is 4.7, and you figure out what is 18.6, which is somewhere in here, right? And 48.8, which is somewhere in here, just below 50%. And all you have to do to produce an ogive is just to connect these points with line segments. The last point should be coinciding with 100%, okay? And that is in the last category between 65 and 69, okay? Now, once you, of course, you write your title, you have a label on the y-axis, you have a label on the x-axis. Notice the x-axis is always the class, whether you're dealing with a histogram or you're dealing with an ogive. It is always the class or the age of the US presidents at inauguration. Of course, the purpose of this ogive is to be able to determine percentiles, and I have a little picture here for you. So if I want to know what is my median or 50th percentile, well, that's obvious. You go from 50%, you hit the curve, and then you go straight down, and it turns out to be 55 years old. Of course, if you are interested only in 50%, you don't need to waste your time. You just look at the US president and look at the median. But what if I'm interested in the 68th percentile, which is somewhere in here? And you have to be really precise when you do ogives. So 68% is somewhere in here. You draw a horizontal axis parallel to this axis until you hit the curve, and then you draw a vertical axis parallel to the y-axis until you figure out that age could be, I don't know, it's probably 59 years old or 60. This, for me, it's not precise because I'm just using my hand, but this is how you find the percentile, okay? Of course, if you're 7 years old, you're older than everybody. You don't need any, right? 100%, go down, it's done. If you're looking for the 20th, you know, like a really young presidents, the 20th percentile means 20% are younger than the age we're going to find right now, and 80% of the presidents are older. So basically, this is a young age. You go straight again, somewhere in here, just above this dot, and you go down, you might get 51 years old. And if it is 51 years old, it means you are in the 20th percentile, which simply means that you are older than 20% and you are younger than 80%, right? That means you're very young, okay? Now, so this is the conversation I actually had with you in class. But what I really want to get to, and this shows up on the AP sometimes, is they give you an ogive and they ask you to produce a histogram. In other words, they ask you to go backwards. A histogram is to graph this against that. An ogive is to graph this against that. Now, even if you're not given this problem, I think it is so important in mathematics to be able to go forward and be able to go backwards. If you are able to go backwards, that means you understand the concepts, even if you are not asked. For instance, let's go back to a basic course you took in the past. Let's say rational functions. So if I give you a rational function, okay, which is a polynomial over another polynomial, let's say I have this, something like this, right? And I say graph it. You probably should be able to graph it by now, right? But what if I give you a graph right? I give you a graph and I say produce a function, it's not this one, of course, produce a function that represents this graph. And let's say the y-intercept is 0, 2, okay? So just because you can graph a function, it doesn't mean you're able to produce a function that represents a graph. It is so important in mathematics to be able to go forward, which nobody forgets, but also to go backwards, which most students forget, okay? You've got to be able to go backwards. So this is an opportunity for you to go backwards because they might give you an ogive and they'll ask you to find, to sketch a histogram. It's not hard at all. Number one, the class doesn't change. So you got 50% done. The x-axis is the same. The question is the y-axis, this or that, right? I like percentages. What you need to do is work backwards. Notice the following. The very first row does not change. You see 2 out of 43, 2 out of 43, 2, 2, 4.7, 4.7. Of course, you haven't accumulated anything other than the first term. So let's go back to something you've done before, which is series and sequences. So let's say I have a series, a sum, okay? I have a sum. And this is basically like a sum, isn't it? Sum. So if I say to you what's S3, what's the sum? S3 means the sum up to the third term. So that is just A1 plus A2 plus A3. S3 is not A3, as some students think sometimes. But if I say to you, what is S1? That means you add the terms until the first term and you stop. So the first term is the sum. But that is not true for any other sum. S2 is not A2, it's A1 plus A2. But for the first term, it is the same. The same thing is happening here. The accumulation up to the first term is just the first term. So that's easy. So if I have this, give me a second. If I have this number, which is given to you because you have an ogive, so they'll give you the ogive. Let's say this is 4.7, it's given to you. Then you just copy it here. It's very simple. That 2 is exactly that 2. And you know the total is 43. So you know this is 2 out of 43. So the first column, the first row is the same. Now, you are given this again. This is the only thing you're given. How do you determine this? You work backwards. So the second row says 8 out of 43. Either we give it to you here or we put it right there and we call this 18.6. So 18.6 or 8 out of 43, you have already consumed 2 out of 43. So you're left with 6. So clearly this is going to have to be 6 out of 43. And of course the frequency, if you care, is just 6 because 2 plus 6 gives you 8. And then I'll do a couple more quickly. Let's say you want to know how to go from here to here. Well, you are at 23 out of 43, but you have already consumed 8 out of 43. You have already consumed 8. This is not just the second one. That's the second plus the first. So 21 minus 8 is 13. So clearly this has to be 13 out of 43, which means the frequency is 13 and the denominator is 43. So it's not hard to actually go from here to here. And once you have this and you already have the class, you should be able to sketch a histogram. Okay, this is a question that shows up a lot on the SAT, and I just want to make sure you get it. All right, I think this is sufficient. It's about 14 minutes. Take care.